All right, so on our last objective, we want to be able to identify the 6 trig values for each angle. So let's go ahead and just look at a generic angle, and then we will go ahead and just look at the actual one. So here we have some angle here. Let's look at this angle right there, right? You know, let's do it in red that way because the hypotenuse is so important, right? That's my hypotenuse right here, which is also the radius of the triangle. Now, the way that I can find the 6 trig values of this triangle is, well, I need a triangle first. So I need my x value, and I need some y value as well, right? And we know that the point where that angle intersects the unit circle is the two sides of that triangle, the x and the y. So now, what if we were trying to find the sine, cosine, and tangent of this angle theta, whatever that angle is? So let's say we wanted to try to find sine of that angle. I wanted to find cosine of that angle, and then I also want to find tangent of that same angle. So this is going to simplify a little bit. These are going to simplify a little bit. So let's see. So the sine of an angle, remember that the sine is going to be your opposite, right? This is the opposite side divided by the hypotenuse. And we'll just label this adjacent while we're at it. So my sine is equal to my y value divided by the hypotenuse, which is the radius. But we know that the radius is really just equal to 1. So now this is going to simplify to be just y over 1, which is anything divided by 1 is just itself, right? So this is just going to end up being y. So that's nice. The sine of theta is really just equal to whatever the y value is on your trig circle, right? So whatever this y value is, that's your sine from now on, right? This is now the sine of that angle. Let's look at cosine. I wonder what cosine is going to become. So for cosine, right, we know that we have the cosine is the adjacent divided by the hypotenuse. So my adjacent side here is going to be x divided by the hypotenuse, which is r. We know the radius is really 1. So x divided by 1 is really just x. So now we know that the x value in this case is really just the cosine of our angle here. And with those two values, I can pretty much find everything else. All right, let's find the tangent really quick, and then we will go ahead and start finding these trig values. So my tangent is the opposite, so my y value divided by the adjacent, my x value. So there we go. All right, now we've got these three formulas to kind of help us out. I'm going to go ahead and write them on our table over here, where we're going to find the 6 trig values for every angle in the first quadrant. It's going to sound like a lot of work, but I mean, it is a bit of work, but it's not that bad. So let's go ahead and first label these. So we know that my sine value is really just the y value, right? So my sine value is really just y. We know that my cosine value is really just x. And then we know the tangent is really just the y value divided by the x value. And let's circle this in black, right? The y divided by the x. Now the cosecant is just going to be, remember the cosecant is just the reciprocal of sine. So we're just going to flip sine. We know that the secant is just the reciprocal of cosine. So I'm just going to take cosine, I'm just going to flip it. And then we know the cotangent is really just the reciprocal of tangent. So I'm going to take tangent and I'm going to flip it. So tangent now is going to have y at the bottom, and it's going to have the x value at the top. So let's go ahead and find our x and y values, and that way we can figure out everything else. So let's go ahead and do that. So at 0, So I'm going to go ahead and erase this. Actually, let's go ahead and move this off to the side. I'm going to go ahead and move this over here because this is pretty important to know. All right, let's go ahead and write down our values, our values here. So we know this is going to be 1, 0. I know this is going to be radical 3 over 2 and 1/2. This is radical 2 over 2, radical 2 over 2, and then this is 1/2 and radical 3 over 2. And then this guy is the 0.01. Perfect, right? We should know the angles by this point. So what I'm going to do right now is I'm going to write down all of the y values here. So I'm going to write down all of my y values. So my y values starting at 0 are 0, right? Let me go ahead and highlight my y values as well. These are all my y values, right? We're starting here at 0, then I'm going to 1/2, then radical 2 over 2, then 3/2, and then 1. So 0, 1/2, radical 2 over 2, then radical 3 over 2, and then 1. We're going to do the exact same thing with my x values. So we're going to start at 0, at 1, then I'm going to go to radical 3 over 2, radical 2 over 2, 1/2, and then I'm going to go to 0. So just writing down all the x values. So the cosine of 0 is 1. The cosine of 30 degrees is radical 3 over 2. The cosine of 45 is radical 2 over 2. The cosine of 60 is, 1/2, is 1/2. And then the cosine of 90 degrees is 0. So with these values, I'm going to be able to find everything else. I can find the tangent, the cosecant, the secant, and the cotangent. So let's go ahead and let's start with our tangent value. Our tangent value is just going to be the y value divided by the x. So my y value is 0, my x value is 1. 0 divided by 1, 0. Cosecant, I'm just going to flip the sign. So I'm going to take 0 over 1 and I'm going to flip it. So it's going to become 1 over 0. Oh, that can't work. So no solution. We can also say undefined. So let me see if I can squeeze that in there. So undefined, right? Or no solution. Either one's fine. Okay, let's go to the next one. Secant is the reciprocal of cosine. So if you take 1 and flip it, you just get 1. The cotangent is the reciprocal of tangent. So if you flip 0 over 1, you get 1 over 0. And if you flip that, you get undefined or no solution. All right, let's keep going. So now let's find the tangent at 30 degrees. So taking the y value and dividing it by the x. So let's go off to the side with this one. So the tangent at 30 degrees, or pi over 3, is the y value, so 1/2, divided by the x value, which is radical 3 over 2. So I'm going to go ahead and multiply by the reciprocal. So this means this is the exact same thing as doing 1/2 times 2 over radical 3. All right, cross out the 2's. I end up with 1 over radical 3, but we have to rationalize this. So I have to multiply the top and the bottom by radical 3, and I get radical 3 over 3. Perfect. So now that's my tangent of 30 here. It is radical 3 over 3. Let's look at the cosine now. Let's look at the cosecant. The cosecant is the reciprocal of sine, right? My sine is now 2. All right, good. My secant is the reciprocal of cosine. So let's do radical 3 over 2 is really the same thing as 2 over radical 3, which we can simplify to become 2 radical 3 over 3. And then lastly, my cotangent is the reciprocal of tangent. So then I just get 3 over radical 3. Oh no, that's weird. Let's see. Let's go back to that tangent one, tangent of 30, and let's see. Oh yeah, if you look at it here, we can just flip the 1 over radical 3. That way we just get radical 3. Done. All right, let's keep going. So now we're at 45 degrees. I want to go ahead and find the tangent. So my tangent at 45 degrees are those two values divided by each other. So if we go off to the side, the tangent of 45 degrees is really radical 2 over radical 2 over 2 divided by radical 2 over 2. Hey, this something divided by itself is 1. Beautiful. So 1. Now for the next one, let's go ahead and flip. Let's flip the sign now to get the cosecant. So I'm going to flip it. I get radical 2 over 2, but radical 2 over 2 can be rationalized to become 2. No, wait, actually, I'm sorry. I need to flip that. Let's flip this. So I should get 2 over radical 2, which ends up just being 2 radical 2 over 2, which the 2's cancel out, and I just end up with radical 2. Perfect. And that's going to be the exact same thing for the cosine, right? The same value. So the reciprocal should be the same value. And then for cotangent, just flip the tangent, and I get 1. All right. Let's go back to, let's now go to the next one. Let's go to 60 degrees, the sine of 6. So I'm flipping radical 3 over 2. Let's see, where else did we do that? Here, right? I took this and I flipped it. So that got flipped and became 2 radical 3 over 3. So I'm just going to write that answer, right? So 2 radical 3 over 3. We're going to go ahead and flip the 1/2, and I just get 2. Now let's find our tangent. Radical 3 over 2. So we're going to go off to the side for our tangent here. Let's go ahead and erase. Let's go ahead and erase some of this. So the tangent at 60 degrees. So tangent at 60 is equal to the radical 3 over 2 divided by 1/2. The 1/2, the 2's are going to cancel, so I just end up with radical 3. That's nice. So radical 3 here, and then we flip radical 3 to get the cotangent. But you know what? We've actually already seen it here. If I get radical 3, its flipped version is radical 3 over 3. Perfect. So now I can see that. Perfect. All right, last one. 90 degrees. Okay, so tangent is going to be the y value divided by 0. This one's undefined. What's the reciprocal for cosecant? What's the reciprocal of sine? It's just 1. What's the reciprocal of secant? So sorry, secant is the reciprocal of cosine. So what's 1 over 0? Undefined as well. And then the last one is cotangent is the flipped version of tangent. So take 1 over 0 and flip it, and I get 0 over 1, and that's just 0. All right, so our entire chart is done. Okay, a lot of work, but the good news is the values repeat over and over and over and over again. So all you really need to do is identify which angle matches up with which one. All right, and I'm going to show you guys how to do that on the next slide. But before we do that, we got one last part. It says what trig values are positive. So if we look at them, everything's positive because all of my coordinates are positive. So here we're going to say all values are positive. Perfect. All values are positive.